This simulation is trying to show us that we have a battery here of about 2. The value is 2.88 volt, and we have, this is a wire. This is our copper wire where we have electrons, and the electrons are being accelerated, as we can see here. They are moving from negative terminal to the positive terminal, but they are moving through a conductor. This side is our conductor. So inside our conductors we have atoms, and here in our conductor has atoms. So these atoms will be colliding, as we can see, will be colliding with our electrons. So this collision of our electrons with the atoms is going to delay them. So this delayance will act as we are resisting the motion of the charge carriers. So this delay due to the collision is what is accounting for our resistance of this conductor. We can easily see that if we increase the resistance, we can see that the motion will be with some difficulty. We are increasing resistance now. We can see that the motion of the charge carriers is with some difficulty. So this kind of suffering the charge carriers are experiencing when they are moving through conductor terminal from here to here, due to the atoms of the collision with the atoms, is going to present what we call resistance. Okay, as we have seen in the previous simulation, charge carriers, in our case electrons, suffer due to the collision with the atoms of the conductor. So this collision with the ions or atom by our charge carrier, in this case we have electrons, is going to slow down the motion, and the slowing down means that they are going to be resisted, or the overall collision problem will present some sort of resistance to the flow of the charge carrier through the conductor. So this the overall effect of the collision is what is going to be called a resistance. So virtually all conductors have some resistance, and this resistance will depend on the conductors. If a conductor has a very, very large resistance, such that current charge carrier cannot appear from one end to another end, we can say that one is a bad conductor, or we can even say it is an insulator. Okay, but a conductor which is facilitating the flow of the current from one terminal to another will be a good conductor, and therefore the value of the resistance will be small. Okay, having the two important parameters well defined in the previous video, we have a law that is connecting them. That this is called the Ohms Law. That when we have a conductor with a particular resistance and we apply some potential across it, which is this is our B, okay, which allows current to flow. So current will flow here. Then our potential and the applied potential, the current and resistance are connected by the Ohms Law, which can easily be stated that the total current you can register when you have this kind of arrangement is proportional to the potential difference you applied here. Okay, so this is a from an Ohm's law, that the current you can register is directly proportional to the potential you apply at the end of the terminal of your conductor. Or you can put the constant of proportionality and you can end up with this version of the Ohm's law, which says that the potential difference across the terminal of the conductor is given by the product of the current and the resistance of the conductor. So here, this diagram is trying to illustrate how we can get each of the parameters from the other two. Here at the beginning, you can evaluate the potential from the product of current and resistance. This is our B. Then if you, after R, you divide both sides here by I, so you can get the resistance to be given by B over I. If you're after the current, you can come to this side, you can divide both sides by R, and you will have this expression to be they want to give you your current. So this is very important law. Any conductor that obeys this equation is normally called ohmic conductor. There are some conductors that they don't obey this kind of equation, and we know we can call them non-ohmic conductors. Okay, there are some conductors that the relation between voltage and current is not this equation.